Hi everybody, welcome to Unit 2. We're going to start off talking about states of matter and changes between those states of matter. Then we move on and talk about atoms and how they are put together, and eventually the organization of the periodic table and what atoms look like on that periodic table. My hair is super weird looking right now. Oh well. Okay, so 4 states of matter should be reviewed: solid, liquid, gas. We see solid, liquid, and gas on our planet a lot. Plasma is what stars and our sun is made of. It's actually a higher energy level than a gas, so we don't see it a lot around here. 3 states of matter are physical properties. So water as a solid, a liquid, or a gas is always H2O. We haven't changed that pure substance, so changing the state of matter, again, is a physical change. So this mixture up here, it looks like a mixture, solid, liquid, gas, but because it's H2O, 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 it is actually a pure substance, but in 3 different states of matter. So what determines the state of matter? It's basically what's going on with those atoms or molecules that make it up. How are they arranged? How much energy do they have? And how much space is in between? Let's look at each of them. So a solid, the particles are super tightly packed, so tightly packed that you can't change the shape and you can't change how much space it takes up. There's no space in between these molecules to squish it any tighter. They're already right next to each other. The particles in a solid are moving. It doesn't look like it, but they're moving a little bit. You actually cannot slow down matter. We have not figured out a way to stop particle movement, just in theory. So even the particles at the table you're sitting at or inside your computer, they're all moving. Everything's wiggling all the time. Liquids, let's just take it to the next level. Now we're going to loosely pack them. So there's a little bit of space in between a liquid, and they actually kind of slide around each other. So this is a liquid, which means it can change its shape, but there's not enough space in between those particles that you can squish them. They're still pretty close together, so they don't change their volume. And again, they're moving a little bit more quickly because now they're sliding around. When we get up to a gas, these molecules are super far apart. There's lots of empty space in between. They're moving around freely. They can take any shape. So think of these molecules moving around, lots of space in between. You can squish them together to change the volume. So gases are the opposite of a solid, basically. And particles are zipping around super, super fast. If we went into a plasma, we would simply be moving the particles so fast that they actually kind of lose electrons and those electrons fly around. So 4 states of matter again, these 3 things. I used to have an animated video here, but it's gone. Another video here we might watch in class. Anyway, how do we change phase or go from solid to liquid to gas? It's all about energy. So everything starts with physics. In physics, you learned about kinetic energy. So it's the kinetic energy of those molecules and how much energy they have. And we change that energy by adding or taking away heat. So we're kind of just putting some fancy words to what you already know. Melting, freezing, we're just adding or taking away heat. All right, to get a solid to a liquid, it is called melting. A liquid to a solid is freezing. When a liquid turns into a gas, it is evaporation. When a gas goes to a liquid, it's condensation. If you want to jump from a solid straight to a gas, we call it sublimation, and a gas to a solid is called deposition or crystallization. I need to add in right here, liquid to gas is evaporation and boiling, and they're very different things. So we will talk about that. So there's a kinetic theory, or the theory of how matter moves, and it has a couple rules. The first rule is atoms and molecules are always moving. That motion changes when the temperature changes. So basically everything's made up of atoms. They are in constant motion. The higher the temperature, the faster the particles. So this is breaking apart what the theory actually says. You need to know this, make it feel logical in your head. If you want to change a phase, again, you add or remove heat. When you add heat, you increase particle speeds. When you remove heat, you slow down the particle speed. That's all we are doing. We are going to do a lab and prove this heating curve. Okay, so I'm going to talk about this later, actually. But it basically just shows the states of matter. So down here you have a solid. Here's the process of melting. Here you have a liquid getting warmer and warmer. Up here you have the process of boiling, and it turns it into a gas. So all those words we talked about fit on right here. You need to pause and build this graph in your notes. and we'll talk about it in lab. Okay, last thing, the difference between boiling point and evaporation, super important. When you boil something, it's happening throughout the entire liquid. So you have raised the temperature, raised the energy in that liquid enough that even the particles on the very bottom are trying to escape up to the top. Evaporation is a surface phenomenon. I love that word. Evaporation doesn't happen throughout the whole liquid, it's just happening at the top. So let's pretend my box here is a box of water. The water molecules up here, remember liquids are sliding around. And if they're sliding around, every once in a while, whoop, one of them is going to fly out as a gas. As you increase the temperature of those molecules, so water's getting warmer and warmer and warmer, there's more of a chance that more of them are just going to evaporate out. But it's not until you have molecules all throughout the liquid that are making those bubbles and turning to a gas that we call it boiling. So boiling requires energy. It happens throughout the whole surface. Evaporation is a phenomenon. It happens on its own. It doesn't require energy. So we'll spend some time making sure you know the difference between boiling and evaporating. That is it, and we'll do some labs.